an exercise. So I've sent you this morning. I hope it's a good file. This one, yes. So the idea here was to analyze existing data and sorry, it's good scale. So we have performed tests in the centrifuge, and at the scale 1/n. Okay, and so we perform tests at 100 G, and for piles that have the same length but different diameters. The thickness of each pile is identical, and externally they are smooth, and they were installed in the dense sand, which was saturated or dry. And we have also the results of the CPT test. So I mentioned the cone penetration test, and for those tests performed at 100 G, we have more or less this slope, 30 Newton per millimeter for the dense sand here. So, so we have the CPT analysis, and the first question that we have to answer is what would be the maximum force during the installation, during checking of the pile. If I want to perform an experiment on the piles, on this type of pile, I want to measure the force. So what will be the range of the sensor? So that's the second question. And for that, I have to try to identify the maximum force based on the CPT. So do you want to think about that, or? Yeah. So the data is on this on this link. I don't know if I am connected here, or yes. Okay, so it's a data paper, and so you have the description of the test in the PDF file, and then different results of tests, 7 results that you can download to work on.
Do you have computers where you can check this, or maybe you can do little groups and share your computers?
Okay, but for the first question, you don't need
and you can discuss the first question.
Voilà. So you see, we have the CPT test result. So with a slope of 30 Newton per millimeter. And then sand, we want to install the pile at 250 millimeter. Okay. So what will change in the different for the different piles is the diameter. Okay. So here.
Noch nicht.
So do you want to play the game, or do you want to have the results? So, by the way, I have here a picture of Gustave Eiffel, who was also a physical modeler in aerodynamics. So the input data, as I mentioned in the text, are collected with CPT. So there are small scale CPT. We have different diameters, and here, in our case, we have those results. In fact, I had two medium dense and dense sand, and when I suggest that we have 30 Newton per millimeter, you can see, well, it's my interpretation. Okay, it's not totally linear. We have more or less linear behavior, but as an engineer and researcher, sometimes we have to make assumptions, simple assumptions to start. And we start with this assumption of 30 Newton per millimeter for the CPT. Okay, do you follow me? Everybody knows what CPT is? Yes. You can say no if you don't know. Who has performed CPT test? Yes, Mike. Okay. At full scale. And you too. Ah, you have a colleague. Sorry? I did not catch it. Do it for experience. Very good experience.
Yeah, yes.
Slope, yeah. No. No, you can see on the two graphs, when the CPT is pushed down, so here is the depth on the vertical axis, we measure the force with the sensor, which is very close to the tip, to the cone, okay? And so we have a profile of resistance of the soil, okay? So if we stop at 100 millimeter, we need this force to install the CPT at this depth. Okay, it's clear. And for CPT in the centrifuge, depending on the type of soil, we have different energy. So for sand, we use hydraulic power because the forces are quite bigger than for soft clay, for which we use we have an electric motor to guide to install the CPT, to perform the CPT test. Okay, so I can deliver here the result. So if we are at 250 millimeters depth, okay, with those results at this scale, so we have in the force, we can record the force at 200. So for the red one, we have 7,500 newtons, and that corresponds to a stress on the cone, which is 66.3 megapascal. Okay, have you found that? Yeah, it's okay. Is it clear? Yeah. Okay. So before installing piles, we have to imagine what could be the force necessary to do that. So I come back to the other file. The Word file. Okay, so maximum forces. Yeah. Okay.
Does everyone has data already? No. This radio has all the data. Good. Okay, so we give Philip then maybe.
Okay, no problem. Oui, mais c'est vrai, je perds le témoin.